Hello again. Welcome back to BackBit Impossible. This is the part where we finally get the project underway. The first two parts I told you about what a BBT is, how the BackBit is different than an REU, and just dabbled a little bit at the beginning stages of my project. Part two, which you just missed, unless you just watched it, tells all about color theory and the problems of taking a Windows RGB, a bitmap, and converting those down to the nearest Commodore 64 color. It is quite math intensive for a 1 megahertz processor, but where there's a will, there's a way, and I found a way. Tables are the answer, and well, if you watched it, great, you know all about it. But we did run out of time there, so I didn't really get to show you the next step, which is this video. Here's the part where I now take my 15-bit color, RGB converted bitmaps that are 64,000 bytes each, and I convert them down to something that actually can be displayed legally on a Commodore 64. And when I'm done this video, this is it. These will be the 8,730 bitmaps that become locked in. This is the basis of what I now try to, I try to turn those into character sets. These are the bitmaps that become the character sets that you see in that video. And well, that's in the parts to come. Don't worry, there's a lot. But anyway, there's a few clips here, so let's get right to it. And yeah, so here we are. This is still early on in the project, probably maybe a week into it. So this all took place, over a year ago. But anyway, let's do it. All right, so here we go.
And this weirdness is because I turned off the computer, but for not long enough that the memory actually completely drained itself. So I rebooted, and I'm doing this properly without the super CPU. And as you can see, starting over, well, it's now writing over the memory that has a partial GABU in it. It's kind of cool. Of course, this is going to take forever. It used to take 5 seconds to do one frame. Now, without super CPU corruption, it's going to take a lot longer. And there's only about 9,000 frames. So I'll let this run for a few hours just to get some footage and see what I'll do with it later. Right in this particular image, you're seeing a multicolor bitmap with the same color restrictions that would be present in multicolor characters. You have a common screen-wide background color and two other colors, 0 to 15, and every cell is allowed only one unique color, 0 to 7. And with that in mind, with dithering, this is the best that this image can hope for. At least with this particular combination of colors, I have locked in colors, I think 1, 5, and 13, just so I get the best grass, and of course a little goat buddy here.
Just like the last program, this here is trying all the global colors via brute force and showing me what they look like. In the end, I realized that allowing the program to do this automated style is not going to cut it because it takes far too long. And as you'll soon see, what it deems to be the best mathematical choice is not pleasing to the eye. It likes grays and boring stuff because naturally those are closer to the center diagonal through this RGB color cube. So in the end, I was better off making the choices manually, and that is what I eventually decide on. By jumping through the video in larger sections like this, I can easily check out a certain color combination myself and get a feel for what it looks like in different things. This is the same evening, about 3 hours down the road, and as you can see, I've already made some progress here visually. It's kind of cool. And here's where my suspicion of purple begins. There is no way this guy is going to look purple. He's awesome, and he's blue. So I thought I'd give the brute force thing another chance. And here we are. It's whittling down the global color choices mathematically, finding the best, what it feels is the best combination to use. And in the end, it chooses colors 8, 12, and 15. Well, surprise, surprise, 2 of them are gray. And so it ends up making a picture like this. But I'm not a computer, and I'm not really fond of that. So I thought, let's try these colors instead. And you'll have to agree, this looks better, does it not? So in the end, yes, even though the numbers don't really make sense, I have to go with my gut here and just realize the computer is not going to be able to do this, or at least the version that I've programmed, because I'm not as smart as I wish I was. Now, I'm not sure why I went back at it, but as you can see, I am going through all the colors one more time here and mathematically tracking them all. Here's the tail end of that. As you can see, the nested loop finally completed. So I break out, I use its best color choice, and once again, it's the exact same image as before. Now, I'm not sure what happened next. Perhaps I decided to say, let's see what the video looks like with these colors because, well, fast forward to the next morning, and we got this. Actually, this doesn't look too bad, does it? But I do change it, and well, whatever. Yeah. And of course, I had to do my test renderings with the Super CPU on. That's why you're getting this interference here. But, you know, I couldn't wait. I just want to, you know, dash out some colors and see what they look like. But it is pretty cool. This is playing Bitmaps back at 20 megahertz.
This was running all night with the Super CPU, and this is still too good. This is a bitmap, multicolor bitmap with the color restrictions that a text mode would have. But it still needs to be dumbed down to 256 characters, and yeah. And it's still got all that glitching because the Super CPU is a piece of shit. I don't know what the deal is. This is just me throwing at some default colors to see what they look like. Every unique scene probably needs some tweaking. Like, look at his nose. It's got bits black appearing here and there because it can't pick red and black in the same cell.
After playing that video back, I thought, you know, I can tweak these colors any way I want. So here's what it looks like when black is set at the default zeros. So I slowly made changes, adding 1 to each RGB component that it considers to be Commodore black. And as you can see, simply by changing this value, the image gets more and more black because more colors get resolved to black. And as you can see with his nose, it looks good. The shadows become more pronounced, and eventually too much is too much. But this is possible with every single color. Just because black is close to 0 doesn't mean it needs to be there. I can make it the equivalent of red if I wanted to. Every color is tweakable. And I didn't go too far, you know, fine-tuning every color, but the possibility is still there. And I love that fact. And I do make use of it later to hide purple because I get pretty frustrated with it.
Okay, I have got the CPU going out of here. It is converting the 5-bit RGB data into a bitmap, multicolor bitmap, but it's following the color rules as if it was a multicolor character set. So this is another intermediate step, because this needs to be reduced down to a character set, which means the 1,000 unique patterns need to become 256 or less. But what I want to point out here is I've got the Super CPU going at it, turbo mode, of course, and it will make terribly corrupted frames every now and then. And to save time, I'm going to do it this way anyway, and I'll go back and I'll flag the ones that are all buggered up and render them again at slow speed, because the program I wrote, I can jump in at any frame I want and end at any frame I want. But the other interesting bit is this is as absolutely fast as a super CPU can go. Now, yeah, we know it's got a turbo switch, 20 megahertz, big deal, right? I have also removed some of the unnecessary bits of code that check for repeated colors. In this case, I know colors 0 and 1 are always in use, so I stop scanning for colors from 7, 6, 5, 4, 3, 2, and then I leave. And the other thing is I have done a few pokes and set the Super CPU optimization mode to GEOS. So it's only mirroring any writes that happen from the 8000 to C1000. Any of those writes get mirrored to the 64 memory. That's the only way that it appears on the screen here, in addition to the I/O stuff. But in terms of rate, when the default is mirror everything, and that's what it happens all the time when you turn it on, I was getting about 12. Oh, look, there's a buggered up thing. Oh, see? Now, to avoid that, I would have to have the Super CPU completely disabled, and it would take about a minute to render each of these frames. But this is fast. Anyway, there's another one. Yeah. Anyway, what am I saying here? By default, it can do 12 frames per second. But with the optimization mode turned on, that jumped to 18. That's a significant boost. And there's 8,730 frames here, and say, well, you get about 18 per minute. Let's say, well, what is that? Times 60, what is that? About 1,000. So this will be about 9 hours just to do this. And that is going as fast as absolutely possible. So you can see why I didn't want to do it at default speed. That would take a week. Oh man. And this is assuming the colors are like I want. I know there's a section later with the Blue Wolf, and it doesn't play very nice, giving it that I'm forcing it to use either white, black, or I think pink. Well, that's kind of looks orange, but it's supposed to be pink. It's color 10, I think. But yeah. All right, it looks like there's a little too much black and a little too much pink, so I'm going to turn down the likelihood of colors being solved to those and try again. This is the second close-up of the Blue Wolf here, using locked-in colors of blue, green, and light blue. Light blue is included because the program won't be able to pick it directly because it's confined to the first 8 colors. But as you can see from like the detail on the snout in particular, we got all 3 colors in play. And the fact that green is one of the colors helps avoid jaggies along the contour here, except at the top and stuff, it's got to choose. Yellow is not one of my choices, neither is white, so it has to pick and choose, right? Black is usually one of the presets that I've locked in, but in this case, when it needs black, it can happily choose it because behind it is usually just blue, which is an acceptable color, a locked-in color. And here's a frame that I have to go back and redo at slow speed later. But anyways, I am very excited about this. Only a few small sections of the video need to be done in a different color. I think the shots with 2 or 3 wolves might need yet another arrangement, but for the most part, just a handful of different color combinations will get the most out of almost everything. I forgot to mention here that I think I have disabled purple again because it was showing up a lot where it shouldn't be, like particularly a snow, which I know is blue or light blue. It shouldn't be purple. I might re-enable purple after and try this again just to see now that I have what I think is a very good choice of colors. We'll see how much purple shows up. I'll show you a picture. Okay, don't use this voiceover, but this, just for my own notes, this is the 0, 10, 13 color combo. No berry tweaks necessary. I am running it at 1 megahertz, and as you can see, it's not very well. It's not very optimized. It's still a bitmap, but yeah, this is looking great. Any color that isn't referenced in the cell is set to, I think, 255, which of course becomes 15 and once it's in color M, but that flag is just for me down the road that I can probably learn to skip those if necessary. But yeah, I'll go over this slowly later and pick out the frames that are corrupted and go back and put them in properly. But boy, look at that, 1 megahertz. And this is just crap. Like, this is, you know, there's no audio, no nothing. I haven't even started with the audio. The audio is going to be easy now, but the video, fine. The colors were slightly adjusted. I think black is set 1 less, so it's a little less likely. Purple has been set below black, like 1 value lower than black, so it doesn't appear at all, because like the grays, for some reason purple is a little bit of an overwhelming color. The computer really likes it. So yeah, we have only 10 colors to choose from, the basic 8, one of which is the global colors, black, and color 10, which is pink or the light red, and 13, which is the light green, which results in the two-tone grass here, and the foliage, which is awesome as well. The worst part, I guess, is the fact that white is now assigned per cell as necessary, and as you can see with the clouds, maybe not so much with the goat, but with the clouds, they turn out to be blocky because it's usually either white or cyan. But yeah, man, this is looking so good. Ah, boy, oh boy, oh boy. This, don't use the audio. This is Quick Test 4. This is one of my debug programs that looks for corrupted frames. As you can see, it's all jittery because it's quick and dirty code to play back the video. I'm looking for corrupted frames that I can document and then go back in and do properly later. So far there's nothing, and yeah. And here's a shot of me fixing frames. You can see one set of frames is getting replaced by the next set, 5 at a time, just wherever the Super CPU corruption took place. This is my first full playback, test-wise, that should have no corrupted frames. They've all been corrected, I believe. Here, the main colors are pink, white, and black. You'll see halfway through, I left it at black, pink, and light green. Notice the improvement. The exception is now white is colored on request, and that's why the background clouds are now blocky, because they have a choice, cyan or white. They can't be both. But I think this is better, so I'm going to put those previous frames back.
Eventually, I added these sprites that show the frame number in question and the 3 global colors that are assigned to that frame. And the sprites, well, my sprite editor is actually Sprite Magic from Compute Books. I've had that thing since the 90s. I mean, I entered it from the magazine. And as time went on, you'd think you would have upgraded to something else, but I never really did. It works, but one day, well, maybe I will write one and use it myself.
This is after all the Super CPU corrupted frames have been fixed, but when you play using the Super CPU, well, new corrupted frames are added because it's reading it incorrectly. But yeah, this is almost as fast as it can possibly do it. It's kind of neat though. It's playing twice as fast as the 24 frames a second originally was.
And that's it for part 3. We now have our 8,730 bitmaps finalized. The next step is going to be turning those into character sets, and that is going to prove to be the biggest challenge yet.